In our last lesson, we looked at these polynomial graphs. We identified whether they were even or odd degree, and we talked about some other features in the polynomial graphs. Now let's use that information to maybe graph or sketch these polynomials ourselves. Recall that the zeros of a polynomial are represented as the x-intercepts in the graph. We looked at that with our quadratic functions. So in number 1, it says the graph of y equals f of x is shown below. What are all of the real solutions of f of x equals 0? In other words, what x values make y equal to 0? So when I go to my graph, we have 1, 2, 3, 4 places where the x value creates a y of 0. We have at -5, -3, -1, and at 0. There are 4 places where the x value makes y equal 0, and those are the real solutions for that graph. Let's do it again in number 2. The graph of y equals f of x is shown below. What are all the real solutions of f of x equals 0? What x values make y 0 on this graph? We have -4, 5, and 8. We have 3 solutions there, 3 x-intercepts, places where our y is 0 on our graph. For the next part, recall when a polynomial is written in factored form, we can take each of those factors, set them equal to 0, and that'll help us find those zeros or x-intercepts of the graph. Again, this is what we also did with our quadratics. Number 3, which equation choice could represent the graph shown below? So again, I've got these 3 x-intercepts, places where the graph is crossing the x-axis. This first one, x is equal to -4. Recall, we can take the factor, set it equal to 0, and solve. So what factor would I need in order for when I solve it to get -4? My factor would need to be x plus 4. When I set that equal to 0, subtract 4 from both sides, I would get that -4. We also have a place where x is equal to 0 and a place where x is equal to 3. Where we're equal to 0, notice in our answer choices, we already have a single x indicating that 0. For the x equals 3, my factor would need to be x minus 3 in order to solve it and get a positive 3 as my 0. So let's see which one we would use. I need a positive 4. So top left is out, top right is out, and I need a -3. I think we are using this bottom right answer choice to match our graph. Number 4, same question, which equation choice could represent the graph shown? We have an x-intercept at -5, +2, and at +5. So for the -5, we would need x plus 5. For the 2, x minus 2. And for the +5, we would need -5. Let's look at our answer choices. I've got the -2 showing up in our top answer choices, but these other ones, they look so different. For that top left one, we have an x squared minus 25. Have you seen something like that before? X squared minus 25 is the difference of perfect squares. Recall that it factors into x plus 5 and x minus 5. Is that what I need here? You bet. Top left is going to match. Our other answer choice had x squared minus 16, which factors to x plus 4 and x minus 4. We didn't need 4s, we needed 5s. So now let's try sketching these polynomials for ourselves. Using the degree, y-intercept, and x-intercepts, we can sketch these polynomial graphs. So let's practice with number 5. Sketch the graph of each polynomial. F of x equals, and it's in this factored form, quantity of x plus 3 times quantity of x plus 1 times quantity of x minus 4. First, let's figure out what the degree is. To find the degree of our polynomial, we're going to add up all of the exponents of our factors. There's understood ones here. So 1 plus 1 plus 1. The degree is 3, and therefore that's an odd number. This can be an odd polynomial graph. Is it positive or negative? Now that question is talking about the leading coefficient. Looking at the very front here, it is positive. So I have a positive odd polynomial. Think back to our last lesson. That means that our arrows are going in opposite directions for that odd, and it's positive going up from left to right. So I've sketched it there. That's going to be the general form of this polynomial graph. Some other pieces we need include our y-intercepts. Or y-intercept, one y-intercept. To find the y-intercept, it's always going to occur when x is equal to 0. Anytime you're going to have a y-intercept, it's on that y-axis, your x-coordinate has to be 0. So let's take our polynomial and plug in 0 for x. So 0 plus 3 in that factored form, 0 plus 1, and 0 minus 4. Our x-intercept is going to be 3 times 1 times negative 4, or negative 12. We'll use that here in a minute to sketch our polynomial. The last piece I need are those x-intercepts, which we easily get from this factored form when we set each of them equal to 0. So for that first vector, x plus 3, as I subtract 3 from both sides, I'll get negative 3. For x plus 1, when I set it equal to 0, we'll have x equals negative 1. And the last one, x minus 4, when it is set equal to 0, the x-intercept will be positive 4. So we'll use all three of those to graph. So here we go. First thing is let's plot all of those points that we know. We know there's a negative 3, x-intercept, a negative 1, a 4, and don't forget our y-intercept of negative 12. We also know the general shape. We're going to have a down arrow on the left side, up arrow on the right side. Okay, so now we just need to try our best to cross through all of those points. Here we go. We're going to go through, back through, cross through that y-intercept, and hump back up. It's not the most beautiful thing, but there is my sketch of number 5, that polynomial. Again, we used the degree and whether it was positive or negative to give us that general shape, the y-intercept, and the x-intercepts. Plotted all those points, went through them. Let's try again with number 6. So let's start off with what is the degree of number 6? We're going to add up all the exponents of our factors. There's 4, understood 1, so our degree is 4. So it's going to be an even polynomial. It is leading with a positive there, so we have a positive even. So both arrows will be up. Let's think, what's our y-intercept? Y-intercepts occur when the x's are 0. So let's plug in 0 for all of my x's in this factored form. And when I simplify, I have 6 times 8 times 1 times negative 1, or our y-intercept is going to be negative 48. X-intercepts. Looking up in my factored form here, we're going to have x equals negative 6. In the second factor, when I subtract the 8, divide by 2, I'm going to have a negative 4. In the third one, I'll have a negative 1, and the last one, a positive 1. Okay, let's plot those. Negative 6, negative 4, negative 1, positive 1, and my y-intercept, negative 48. Try to eyeball there when you're working on delta math. We also know that our polynomial is an even positive, so both arrows are up. Let's try our best to connect here. We're going through that negative 6, through the 4, through the negative 1, drop down to that y-intercept, and shoot back up for your final leg of your polynomial. Number 7, what is the degree for number 7? We've got 1, 2, 3 understood 1 exponents there, so we have a odd degree polynomial. It is positive. So just like our original example, we've got arrows going opposite directions, but up from left to right because it's positive. The y-intercept, as I plug in zeros here, I'll have a 3 times a negative 2 times negative 5. So we'll have negative 6 times negative 5. We have a 30 as our y-intercept. X-intercepts, looking at my factored form, I'll have -3. On the middle factor there, I'll add 2 to the other side of my equation, divide by 2. I have a +1 and +5. Let's plot all of those. -3, +1, 5, and my y-intercept was a 30. Okay, we did know arrows are going opposite directions, up from left to right. So let's go up and through. Let's catch this y-intercept, coming back down through the 1 and back up through 5. 2 more examples here. We do have a note up here that we will indicate here in a moment. When we have those even exponents on our factors, we're going to bounce on that intercept. So let's first identify our degree. So adding up our exponents on our factors is going to be 3. 2 plus the 1. We have a 3, so odd. Again, it's leading with a positive, so positive, odd, opposite directions, going up from left to right. Let's identify our y-intercept. As I plug in 0, we're going to have a 1 squared. This could be significant in other problems, so I do want to make sure you notice we have a 1 and it is being squared. When I plug in 0 for the second factor, we'll have -4. That's just going to give us a -4 for our y-intercept. X-intercepts, using those factored forms, we've got x equals -1. Now, I like to make a note to myself that it's going to bounce. I circle it, I star it. Because of that squared, we are going to bounce at that -1. And then my other factor, I would add 4 to the other side, divide by 4, we have a +1. So I do want to bounce on this point, on the -1. So let's plot it. We've got -1, +1. Our y-intercept was -4. We are odd positive, so down on left, up on the right. I'm going to go bounce on this -1, turn away from it. See how I didn't go through? Coming back through my y-intercept and all the way back up. This doesn't have to be perfect, but Delta Math definitely wants you to hit each of those points, the x-intercepts and the y-intercepts. So we bounced there on that -1 because we had a squared or any even. If it was a 4, if it was a 6, any even exponent or degree on your factor, we're going to bounce on it, okay? Let's try again. Number 9, let's identify our degree for number 9. We've got a 2, that counts as well, 3, 4. So we have an even polynomial. Notice this time, finally an example that's negative. So both arrows are going to be down. For our y-intercept, plugging in zeros for x, notice this one works out a little bit differently because as I plug in that 0 for that first part, -4 times 0 squared is 0. That's going to be multiplied with the 7 and the 4. Our y-intercept is 0. X-intercepts. Make sure you also solve that front part, -4x squared equal to 0. When I solve that out, dividing by -4, x squared will equal 0. The square root of 0 is 0. You're going to have an x-intercept of 0 for that first part. Second factor will have a -7, and the last one a -4. So let's plot all of that information. We have a 0 x-intercept, and that comes from that front piece there. We have a -7, -4, and our y-intercept was also 0. Go figure. We know that both arrows are down. And then don't forget, we are going to bounce because of that squared on that 0. So at this point, you know both of those arrows should be down. So if you're not bouncing where you're supposed to bounce, you're going to notice, hey, my arrows aren't ending up where they're supposed to be. So I'm going to erase some of this to give us some room here. I know both arrows are down. All right, we're going to go through -7, back down through -4, come up to 0 and bounce back down, right? The -4x squared at the beginning had that squared, so that's that gave us our x equals 0, which is also where we bounced. We knew both arrows had to be down because of it being an even degree and a negative leading coefficient, so I've got both those arrows down. Again, Delta Math is pretty flexible with your sketching part, which is the tricky part, as long as you have your X and Y intercepts plotted correctly. So that's how to graph or at least sketch your polynomial functions. Again, we're using that information from the last lesson about even and odd degree polynomials, positive and negative, what their general shape is. And then we went back and we really focused on when we're in that factored form, really does reveal those x-intercepts. When you are sketching on Delta Math, you do have to find, like we modeled, your x-intercept and your y-intercept, and you will plot those on Delta Math and try your best to sketch those humps and those bumps. Don't forget to bounce when we have an even degree on our factor or maybe on your variable like we saw on number 9. And good luck, guys. I love graphing polynomials, and I hope you do too. I'll see you in class. Have a great day.